Alright, here we got to do 9.7. We're going to talk about vertical and horizontal asymptotes. It's all the same stuff we were doing before, only now we have to do it with different types of powers on the bottom and the tops of our stuff. We're still going to look at, for a vertical asymptote, our denominator when it is equal to 0. Our vertical asymptote is still the part here going up and down that our graph is not going to touch. It does not touch that because we cannot have, I don't know, it doesn't even matter what's going on up here. We can't have 0 on the bottom of our fraction, which is why our graph is not going to touch anywhere near the vertical asymptote. So we are still just going to solve for the bottom of our fraction equal to 0. So if it's x plus 3, all we have to do is put that equal to 0. That means x is going to equal negative 3, and that's all we're doing. So here, now we've got two different x's down here on the bottom. That means we really have, what, x squared plus 3x. And as soon as we start getting bigger powers down on the bottom of our fractions, we are going to end up with more than one asymptote, one for each one of those powers. So we need to split that up just like we did back in second quarter or something like that. Set both of those equal to 0 on their own. Since this one's already solved, we're good there. We got to subtract 3 from both sides here to get x equal to negative 3. So those are two different asymptotes. And as you can imagine, that's going to make our graph look kind of weird. So here you can kind of see there's the one asymptote, and there's the other. You're not going to have to actually graph these, but I just wanted to see, kind of where these things were and why they were going to get more than one asymptote happening. Alright, and in this case, you're definitely going to have to factor. I know you hate that because you don't remember, because we've only been doing it for 4 months. So x minus 3, x minus 4, because negative 3 and negative 4 multiply to make the 12, but they add up to make negative 7 here on the inside. Those are not our two answers. We then have to change their signs and get x equals positive 3 and positive 4 for our two different asymptotes for that one. Alright, difference of squares. Never told you needed to remember this, but it keeps coming up anyway. So what's the square root of 36? That's 6, so that's our x plus 6, x minus 6. So our two different asymptotes are going to be at the positive and negative versions of 6. That's what that's going to look like here. We got our negative 6 and our positive 6. So you can kind of see where those two different lines would be. They're not actually there because they're not actually part of the graph. But this is what that kind of thing would look like. Aren't you glad you don't have to graph that? Alright, so finding our horizontal asymptotes is a little bit different. This is the one thing that we're doing today that's actually going to be brand new. For degree of our numerator, that's the top of our fraction, is equal to the degree of the denominator, that's the bottom. Then we do what we were doing before, and we're going to divide our leading coefficients. So that's something when we have like 2x plus 3 on top, and then like 4x plus 1 on the bottom. You take your front numbers, and that one would come out to be positive 1/2. So when things change and they're not the exact same, that's when stuff is going to be different. If our degree on our top is less than the degree on the bottom, then we get to just go with y equal to 0. So if we've got x on top and like x squared plus 3 on the bottom, our degree on the bottom is bigger, so that means we are just going to write y equals 0. The reasoning for that, I'm sure you don't care, so I won't even bother with it. Alright, if the degree on top is greater than the degree on the bottom, then there is not a horizontal asymptote. So that means if we got like x squared over top of x plus 3, now that our degree on top is bigger, there is no horizontal asymptote, and that's just one of those that's just, old school kind of graphs where it's just going to go forever left and right and never actually flatten out to a particular asymptote. Alright, so looking for our horizontal asymptote, every time you see that the powers of x's are both the same, x squared and x squared, all we do is we take the front numbers, 15 over 5, that's 3, so our asymptote's at y equals 3, and that's it. So all these next ones here, that's all we're going to do. And here you can kind of see that flattened horizontal asymptote going off here at 3 that our graph is never going to touch. If only I could draw a straight line, right? Alright, again here, x and x are the same, so we're just going to go with y equals 9 over 9 is just 1. X and x is the same, so y is going to equal negative 5 over 4. X squared and x squared, they are the same, so we just worry about those front numbers, and y equals 7 over 3. Now as soon as we see something different, we don't even have an x on the top here, so that's like x to the 0. That's definitely less than x to the 1. So if our bottom is bigger, that means we just go with y equal to 0. This is just like what we were doing yesterday, except there's no number out here, which if there's no number there, it's 0. So you already knew that one anyway. And here's what that one looks like with our asymptote there at 0. So again here, power on top's a 1, power on bottom's a 3. So it's just y equals 0. Easy. Alright, finding our x-intercepts. If we have a graph, we have an x-intercept like here, or maybe here, or wherever. Those are the situations when y equals 0, because we did not go up or down, we just went left or right. If y equals 0, that means whatever our fraction is has to equal 0. So whatever's going on top and bottom has to come out to 0. That means the top has to be 0. Doesn't matter whether you got x plus 4 down here, whatever. Top is 0 is the only way you're going to get 0 here. So that's why we're going to figure out what happens when our numerator is 0. In this case, our top is 3. Does 3 equal 0? No. So that means there is no x-intercept. Why isn't there an x-intercept? Well, since our power is bigger on the bottom, that means our asymptote's at y equals 0. So that means the asymptote is along there. If it's along the x-axis, you can't touch it. So that means our graph is not going to go through there. So that's the weird situation. The rest of these, we just put them equal to 0 on the top here, subtract 5, so x is going to equal -5. And just kind of go through that stuff. 0 here, so we're going to take the opposites of both of these. So x is going to equal +1 or -3. These are all those solving things that we did way back in like December or something like that. 3x equals 0. We would divide by 3, both left and right. 0 divided by 3 is going to stay at 0. Alright, this part starts asking us about all the asymptotes. We got a whole lot of examples of these, so I'm probably going to cut this into video 2. So go ahead and take a look at part